Hi children, how you are? Are you happy? So today I am going to teach you concept 3. Okay na? That is from atomic structure. So you know that is concept 3. That is what? Quantum numbers. What is present in this? In order to explain the structure of atom, 4 quantum numbers are given. Those are, that is called as తీసేయండమ్మా, remove చేయండి. So 4 quantum numbers are given. That is first one ఏంటి? Principal quantum number. Principal quantum number. Second one is azimuthal quantum number. Azimuthal quantum number. Third one is magnetic quantum number. Magnetic quantum number. And fourth one is spin quantum number. Spin quantum number. So these are the 4 quantum numbers to explain the structure of atom. To explain the structure of atom, 4 quantum numbers are given. Different scientists proposed different quantum numbers. That is called as quantum numbers. So first one is principal quantum number. First one is what? Principal quantum number. So let us discuss about principal quantum number. Who proposed this quantum number? Bohr. This was proposed by Bohr. First point should write, this was proposed by, first point, it was proposed by Bohr, Niels Bohr. First point. And it is denoted by principal quantum number is denoted by small n. You know Bohr's model, first orbit, this one, that is equal to n is equal to 1, symbolized by k. Second orbit, n is equal to 2. Third orbit, n is equal to 3. First orbit, n is equal to 1. Second orbit, n is equal to 2. Third orbit, n is equal to 3. So n value starts from 1, 2, 3, 4 and so on. N value starts from 1 to 3. And fourth point, for n is equal to 1, that is symbolized by K shell. This is K shell. Already we discussed in Bohr's atomic model. So n is equal to 2, that is K shell, K shell kaadu, L shell. L shell. N is equal to 3, that is equal to M shell. N is equal to 4, that is equal to N shell. So first one is, this was proposed by Niels Bohr and it is denoted by small n, and n value starts from 1, 2, 3, 4. N value is equal to 1, K shell or K orbit. N is equal to 2, L shell. N is equal to 3, M shell. N is equal to 4, N shell. Okay na? Next, in this fifth point, radius of the orbit, radius of the nth orbit, radius of the nth orbit 0.529 into n square by z, n square by z. Size of the orbit increases. So it tells about the size of the orbit. This quantum number, principal quantum number, signifies the size of the orbit or radius of the orbit. First orbit radius, second orbit radius, third orbit radius, fourth orbit radius, increasing the size of the orbit. So that is 0.529 into n square by z. Suppose here n is equal to 1, first orbit, z is always 1 only here, according to the Bohr's theory. It is applicable for only single electron. That's why Z is equal to 1 only, atomic number 1. So that is Z is equal to 1. N different orbits. First orbit. So answer is what now? 0.529 into n square by Z means 1 square by 1. So answer is what? N square by Z. That means n square by Z value 1. Here angstroms also there. So 0.529 angstroms first orbit. Second orbit 2 square. 0.529 into 2 square. 0.529 into 4. Then you will get 2.116 angstroms. Like that you can find out the radius or size of the orbit. So this quantum number signifies the size of the orbit or radius of the orbit. 6 point. Energy of an electron minus 13.6 into Z square by n square. First orbit how much amma? Minus 13.6 into Z square, atomic number 1 square by n square. First orbit 1 square. So answer 1. So this is electron volt per atom. Here only write electron volt per atom. So answer is minus 13.6 electron volt per atom. This is the first orbit energy. Okay. So you can find out the radius of the orbit, energy of an electron. So signifies the radius of the orbit and energy of an electron. It signifies the radius of the orbit and energy of an electron. That was proposed by Niels Bohr. Next one, number of orbitals in the nth orbit. Next, 7th point. 7th point, number of orbitals in the nth orbit. So formula n square, first orbit 1 square. So how many orbitals are there? 1. That is 1s orbital. You know that 1s orbital. That is 1s orbital only. Suppose second orbit 2 square. Then how many? 4. What are those? 2s and 2p. S 1 orbital. Any s orbital is 1. Either 1s orbital is 1, 2s orbital also 1. 2p orbitals 3. px, py, pz. S orbital is always 1. So these are 3. These are 1. This is 1. This is how many? 3. 1 plus 3. Total 4. Like that, remaining third orbit 3 square 9. 3s, 3p, 3d. 3s 1, 3p. How many 3 orbitals? D 5. 1 plus 3 plus 5 9. So substitute that formula n square. Next one, 8th point. Number of electrons in the nth orbit. So answer is formula 2n square. So 2 into 1 square, first orbit. So how many? N is equal to first orbit. How many electrons you can fill? 2 electrons. 1s. You can fill how many electrons? 2 electrons. One is upward direction, another is downward direction. So next, second orbit, if you see, n is equal to 2 into 2 square. 2 into 4. How much it is? 8. How many electrons you can fill? 8. 2s you can fill 2 electrons. 2p you can fill 6 electrons. 1, 2, 3, 4, 5, 6. Okay. Orbitals 4 total. Orbitals here 4. Total orbitals 4. Electrons 8. So substitute like this, you will get the concept. Right. So this is about the principal quantum number. Today I explained about the principal quantum number and the introduction part. Quantum numbers means what? Today what I explained, quantum numbers. To explain the structure of atoms, 4 quantum numbers are given. First one is principal quantum number, second one is azimuthal quantum number, third one is magnetic quantum number, fourth one is spin quantum number. Next I explained principal quantum number clearly, 8 points I explained. Okay, so this one you practice and come to the class. Principal quantum number, everyone should read these 8 points and come to the class. I will ask the questions, you have to say that answers. Thank you children, bye.